So, how do you take a simple app, something you might have built in your garage, and turn it into a global service that can handle millions of users without, completely melting down? Well, today we're going to build the blueprint for doing just that, designing for massive scale.
I mean, it's a great question, right? You build something awesome, it starts to take off, and then all of a sudden, the very thing that made you successful, all that popularity, is the exact thing that's about to bring your entire system to its knees. That right there is the challenge of scaling. It's what separates the garage projects from the global platforms.
Okay, so to make this all feel a bit more real, we're going to design a service you've probably heard of, Pastebin.com. On the surface, it seems super simple, right? You paste some text, you get a link. Easy. But, as you're about to see, scaling even a simple service like that to handle millions and millions of users, that takes some pretty serious engineering.
Now, before we write a single line of code or spin up even one server, we have to tackle the most critical phase of all, the planning. We've got to create a blueprint. I mean, think about it. You wouldn't build a house without one, right? You have to know what you're building before you ever start laying the foundation.
And here's the exact process we're going to follow. It's a really solid 4-step method. So first, we'll outline what we're actually building, the use cases, the constraints, all that stuff. Then we'll create a high-level design, kind of like a bird's eye view. After that, we'll dive deep into the core components. And finally, the big one, we figure out how to scale the whole thing up. This is our roadmap for today.
All right, so let's start with step 1. What are our core features? Well, a user has to be able to create a paste. The system then needs to generate a unique link for it, and of course, anyone with that link should be able to view the paste. We also want to add an expiration time for these pastes. And this is a big one, the whole system needs to be highly available. That just means it has to stay online, even if some of its parts fail. We're keeping it simple and focused for now.
Okay, our requirements are set. It is time for version 1.0. This is what you might call the get it working stage. We are not thinking about 1 million users right now. We just need something that actually works for, say, our first 100.
So, our initial design is, well, it's about as simple as it gets. We've got one web server, it handles everything. All the logic for creating pastes, generating the links, showing them to people. And where does all that data go? Yep, into a single database. For a small number of users, this is perfect. It just works.
But then, it happens. Our little service gets a shout out on some huge website and boom, the users just start flooding in. And what was a happy success story a minute ago is very quickly turning into an absolute disaster. Our simple, elegant little design, it's about to break hard.
And look, we're not just talking about a few more users here. We're talking about millions, 10 million to be exact. And every single piece of our simple little setup is now under a kind of stress it was never, ever designed to handle.
So here's the heart of the problem. Our one and only web server is completely overwhelmed. It's a total bottleneck. In our database, it is just getting hammered with requests and it's slowing down to a crawl. The big question is, what do we do now?
Okay, this is where the real fun begins. This is the engineering solution. We're not going to just throw our app away and start over. No way. We're going to evolve it. We're going to start adding new, specialized parts, and each one is going to be designed to solve a very specific problem that our crazy growth has created.
First things first, that overwhelmed web server. The solution? A load balancer. See, instead of having just one server, we're going to have a whole fleet of them. The load balancer acts like a traffic hop. It stands out front and directs all the incoming requests evenly across our fleet of servers, so no single one gets buried in work. This is what engineers call horizontal scaling. You solve the problem by just adding more machines.
All right, next up is our slow database. Think about it. For those super popular pastes that get read over and over and over again, does it really make sense to hit the database every single time? No, it doesn't. And that's where a cache comes in. A cache is like a super fast, short-term memory for our system. We store copies of the most popular stuff in there. So now, when a request for a hot paste comes in, we can just grab it from this lightning-fast cache without ever having to bother the database at all.
Another really powerful trick we can use is database replication. A super common way to do this is with a master-slave setup. Here's how it works. You have one master database, and its only job is to handle all the writes, so all the new pastes being created. Then, it copies or replicates that data to a bunch of slave databases. Their only job is to handle the reads. It's a beautiful way to split the workload. There's also a master-master setup, which is a bit more complex but lets you write data to multiple places at once.
But what about our users on the other side of the planet? It's going to be slow for them, right? The data literally has to travel thousands of miles. To fix that, we use a content delivery network, or a CDN. Just think of it as a global network of servers that keep copies of our most popular stuff. So, when a user in, say, Tokyo requests a paste, they don't have to wait for it to come all the way from our main servers in Virginia. Nope, they get it from a server right there in Tokyo. It is a massive, massive speed boost.
So let's put it all together. Look at this. We have totally transformed our system. Remember that single little server and database we started with? Now we have a robust, distributed system. By adding a load balancer, a cache, those database replicas, and a CDN, we've systematically knocked out every single bottleneck that was threatening to crash our service. This is a design that can handle millions of users.
So after all that, what's the big takeaway here? I mean, it might look like we just kept adding more and more boxes to the diagram, right? But the real art of system design, it's not about adding stuff. It's about understanding and managing trade-offs. And a perfect example of this is the famous CAP theorem. It basically says that in a distributed system, you're often forced to make a tough choice. Do you want perfect consistency, meaning every single user always sees the absolute most recent data instantly? Or do you want perfect availability, meaning your system is always online and always responds, even if the data it gives back is, a few milliseconds out of date? The thing is, when things go wrong with a network, you can't have both. You have to choose. You have to make a trade-off.
And really, that leads to the phrase that sums this whole thing up. Everything is a trade-off. There's just no single right way to design a system. Should you spend more money on faster hardware, or should you add more complexity to make the system more reliable? Every single decision. It's a balance.
And that really brings us to the end of our journey today. We've walked through the entire blueprint, from a simple idea all the way to a system that can serve millions. So the final question, I guess, is for you. Now that you know the process, defining the scope, sketching out the design, building the core parts, and planning for scale, what system would you want to build?